Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to study a very important topic of class 10 NCERT, that is sign convention for lenses, specifically lenses, and then we'll study about the lens equation for class 10. So without wasting time, let us dive in straight to the class. To the class. So here comes the sign convention. So if you want to study about sign convention more clearly, we have already taken classes on the sign convention for mirror case. So in the mirror case also, we have studied sign convention, and here also we are taking the same sign convention in the case of lens also. So now the thing is that if you haven't seen the videos on that sign convention for mirror, I will put it somewhere here so you can go there and just go through that thing and come back again. So here also again I am just saying the sign convention for the lens case. So here for convenience I'm just taking the lens. Which type of lens? A convex lens here. So now imagine that the light ray is coming from left to right. Okay, so from the source where I'm keeping the source, if I'm just keeping a source here, just imagine that there is a torch here. If I'm just lighting and I'm just taking a single ray here, and the direction of the light ray is in this way, right? So that will be our basic direction, or simply we can say the reference direction will be that the direction of the light from the source. Okay, keeping this in mind, that is the direction of light from the source, we are just kind of saying that how we can just give a positive sign or negative sign, or assign the direction, assign the values, assign the signs to the different attributes. So here the main idea of sign convention is that what will be the sign of u means what? Object distance. What will be the sign of v means what? Image distance. So whether this will be positive or negative, we need to know that thing. And here also we need to see, we need to find out whether it is positive or negative. Okay, now two more attributes are there. Height of the object, that is ho, whether it is positive or negative, and hi, that is height of the image. We need to know whether it is positive or negative. Why we need to assign the values of this positive and negative? The main idea of physics behind this is that these all are directions. So these all are directions means we need to have a particular value, positive and negative, because the next case or the next session we are going to study about the lens equation, right? In that lens equation we need to assign this value and get the correct answer. For that reason we are going to assign the value. Okay, so here in this case that all the attributes or all the values that we need to know with the same direction will be given as positive value, and opposite direction will be given as negative value. So what do you mean by that? Just imagine that there is an object. I'm just keeping an object here, and this is a convex lens, and I'm just saying that this one will be the optic center C, and then imagine that this is a principal focus, and this will be 2 times the principal focus, and you know that. So here if I'm keeping an object AB here, then definitely the u will be taken. That is, u means what? The object distance. Object distance is taken from which direction to which direction? All the directions will be taken from this C. Okay, so if I want to find out the u, then I will calculate the distance from this particular center of optical center C to that particular object, and this is calculated as object distance and denoted by the small letter u. So here if I'm just closely watching, then I can see that this object distance, the object distance is calculated from optical center to this particular object, which is opposite to the direction of the incident light, or opposite to the light falling from the source. So whether it is in same direction or opposite direction, obviously it will be in opposite direction. So what is happening here? Which sign will be assigned to that u there? The opposite side will be given negative value. So this will be a negative value. Got it? Now, in this case, you can see that we are obtaining a real image which is falling somewhere here, right? Okay, somewhere here. Here, if I want to find out the image distance, then the calculation will be taken from optical center to that particular image, right? Let this be A dash, B dash. Okay, fine. And now, this is V. V is what? Image distance. And this image distance is calculated from optical center to the particular image. And now closely see whether it is in the direction of the incident ray or whether it is the direction of the light falling from the source. Yes, it is in the same direction as that of the source. So which sign will be assigned to that particular image distance? It will be positive. We all know that one of the cases of this particular convex lens will give you what? Which image? A virtual image. Virtual image means what? It will fall in the same direction as that of the object, right? In the case of virtual image in the lens, you can see that it is falling on the same side of the object, and that means it will just take which sign? It will just take the negative sign. Why? It is calculated from the optical center. It is calculated from the optical center to that particular point, and then we can clearly say that it is in opposite direction to that of this particular V. V means what? Image distance. So that will have a negative sign. What about HO and HI? Height of the object and height of the image. Here in this case, we can see all the values which is coming the upside of the principal axis will be positive, and all which is coming at the downside will be given negative value. So we have seen positive, negative, right? It is according to whether the object is above the principal axis, then we can say it is erect, so we will give you positive value. And if you're getting a virtual image, then definitely you can see that which is also falling on the same side and also upright. So what you will say? It is positive, right? In the case of height. Whereas if you're getting a real image, then definitely it will be falling in the other side. And also one more thing, it will be upside down, inverted, then it will have a negative sign. So this is about the sign convention. It's very important. Why? Because if you are going wrong with the sign convention, you will definitely lose a good marks. Why? Because in the case of the next session where we will study about the lens formula, there you need to just give the same values and then assign the values, assign the signs, and then only you will get the correct answers. And also one more thing, according to the sign, we can interpret the nature of the image form. So sign convention is very important because we can interpret. How can we interpret it? Here itself we can say, if u is negative, that means what? Always it will be kept, or u will be calculated opposite to the line. And in most of the cases, and in 100%, we can say u will be negative. The basic misconception of this sign convention. Basically, we used to have this thing, that is, we had studied in mathematics about the coordinates, right? Or quadrant. And here, those who had studied about the graph, we all know that those values which is coming in the right side, this will be positive, and on the left side of an axis, just imagine that this x-axis, then right side of x-axis will be positive, left side of x-axis will be negative, and if this y-axis, then upside will be positive and downside will be negative. Arrow mark should be given there, otherwise it will go wrong. Okay, but is it wrong? Is it correct? Okay, in the case of mathematics, it is correct. But if I'm just keeping a lens here, which type of lens? Convex lens. Then, according to the previous section, everything will be right. On the right side, it will be okay, left side will be negative, upside will be positive, downside will be negative. But in this particular case, just imagine that you have a lens in your hands and you're keeping an object here. you're keeping an object here, and then what happens? A light ray is coming here and it is going like this. And imagine that you got an image here. In this case, what will be the sign convention? If you're just calculating the sign convention like this, usually like that of a mathematical quadrant system, then what happens is a big blunder will happen there. Why? Because here you will be what? Always positive. Why? Because according to this mathematical thing, the right side of x-axis will always be positive. Here, this is the optical center, then optical center to the object will be taken as u, and optical center to the image is taken as v. Then what happens there? You will be always positive, and here in this case, we will be what? We will be negative. But actually, is it so? No. Why? Because we want to give the value or assign the value with respect to the direction of light coming from the source. So what happens here? Actually, what should be the thing? So this will be going wrong. What should be the thing? The light direction. Then you need to find out the direction of light is in this way, right? So u is opposite to the light falling, right? Just imagine, see here. This is the light direction and this is the u direction. Then that will be opposite. So u will be negative only. And in this case, you can see the direction of v is this way, right? Why? Because all the calculations are taken from the optical center in the case of a lens. And the direction of v, so direction of light is same. So both have same direction. So same, both are same in this case. So v will be positive. So actually u should be negative, v should be positive in this case. So this one is correct. So make sure that see the question carefully and see from which direction the light from the source is falling, and then you need to assign the positive value and negative values carefully. Here and here the upside HO and HI will be given positive and negative according to what? The upside. Whether it is upside, then it will be positive. Whether it is inverted, then that will be negative. So no confusion in high case, but make sure that you go carefully with the what horizontal thing, that is u and v. I hope that you got the points, right? So this misconception should be taken away and ideas should be clear, physics should be clear. So we'll just go straight to the lens formula. So here comes the lens formula. So here comes the lens formula. There in the case of mirror also we have studied a very specific, very important formula, that is the mirror formula. There we had studied a relation between the f, v and u. So here also we are going to study the relation between f. F means what? Focal length. V means what? Image distance, and u is object distance. So there is a very important relation. This is also a very important relation to find out the nature, position of the image formed. So what is this lens formula? And the lens formula goes like this. That is the reciprocal of focal length is equal to the difference between reciprocals of image distance and object distance. That is 1 by f is equal to 1 by v minus 1 by u. So this is the lens formula. Very important question, very important theory, and very important formula. So this particular part will give you a good amount of marks for your board exams. Okay, so coming to this particular thing. So here comes the idea of lens formula and idea of this particular sign convention. So make sure that you give the sign convention correctly and then you will get the answer correctly. Okay, in order to understand this lens formula as well as sign convention, we'll just go with one or two questions and we'll see how we can just solve the problems. Okay, just imagine that you have a convex lens in your hand. Okay, fine. Here comes a convex lens. Okay, in this case, you are given certain values and you need to find out the unknown values. So how can we do this thing? Just imagine that you have an object distance of 12 centimeter in your hand. That means you have an object which is placed 12 centimeter from the optical center, that is 12 centimeter is the distance. Okay, and it is also said that the height of the object, that is HO, is 7 centimeter. And one more thing, one more value is given there, that is the focal length. The focal length of the lens is given as 8 centimeter. And you are asked to find out V. What is V and what are the nature of the image formed there? So how can I find out the position as well as nature of the image there? So just pause the video and try to do yourself and see whether you can just tackle the problems in a good way using the both sessions. Okay, let us see what happens here. So before starting, I need to know that which lens is given in your hands. It is a convex lens is given in your hands, and you know the focal length or the focus will be fallen here, right? Here, then only you can say most of the light is, what type of lens is this? It is a converging lens. So definitely all the light will be fallen on the other side in the real way. So you can see this is a focal principal focus. So focal length, which is calculated from the optical center to that particular point. Which point? Principal focus is known as focal length. Okay. So this focal length is like this. Now understand that what will be the V. So V can be calculated from the lens formula, which is given by 1 by F is equal to 1 by V minus 1 by U. Got it? From there, 1 by V is equal to what? 1 by F plus 1 by U. So this is the major equation, right? This is a major equation, that is equation 1. From there, you are just rearranging and finding out an equation which is needed for this particular question. Okay, now what happens? Here, what you need to know is that giving the correct values of the or signs or the sign, whether it is a positive or negative values for the values or the attributes given in the question. Okay, so 1 by V is equal to 1 by, what is F? It is, F is what? 8. But we need to know whether it is a positive sign, negative sign. 8, this value, focal length is calculated from the optical center to the principal. So direction will be from left to right. And what is the direction of the light? Incident light. Then it is also coming from this way, right? From the object to that particular way, or this way. This direction is same as that of the principal or focal length. So focal length will be positive, right? Okay. Plus 1 by, what is U? It is 12 centimeter, but make sure what will be the sign. So here in this case, this is incident light and this one is principal focus or focal length, sorry, focal length. And what sign will be given for U? So here also the reference direction is the direction of the incident light, like this, right? And the U is calculated from optical center to this particular, this way, optical center to that object. So the direction will be this way. And that is both are opposite direction. So it will be negative. And moreover, in this case, and 100% for your 10th standard, and in the nature, you will be what? Negative itself. Why? Because the incident object or incident light is taken from the source and the object itself is considered as the source of light. And here we can see that is 1 by 8 minus 1 by 12. From there we can say 24 is the LCM. From there 3 minus 2 by 24, and that is nothing but 1 by 24. Then that is 1 by V. And so what will be V? V will be equal to 24 centimeter. So very good thing. Here a positive sign for V. V is positive. What does that indicate? So it indicates that V will be positive or same direction as that of the incident ray. So V will be here, right? That means V will be fallen somewhere the right side of the lens, or this side, this portion. So V is a positive sign, and that is 24 centimeter from the optical center to the right side. And positive part of a convex lens means that it is what type of image? It is a real image. So this one will be a real image. And all the real image will be what? Inverted image 2. But we need to prove that whether it is an inverted image or what it's an erect image. We should get an inverted image only. Why? Because real images will be inverted image, and inverted image should have a negative value for hi. So we'll find out whether what will be my height of the image. Let us see what happens there. Magnification is one of the term which is coming here. So we'll study what is this magnification here. Then we'll go with the next part of this particular question. Magnification means it is a ratio of height of the image to height of the object. Height, how much the height of the image with respect to height of the object, or how big or how small is the image with respect to the object. This is what the magnification means. And here one more equation is there which is related to V and U, or image distance and object distance, that is V by U. This is very important, very, very important. In mirror case, we had studied Hi by Ho is equal to what? Minus V by U. But here in the case of lens, it is V by U. So from this equation, we can get a very important thing, that is Hi by Ho is equal to V by U, and that is, what is V? It is 24 centimeter, right? It is 24 divided by what is U? And U is 12 centimeter, but one minus sign is there. Why? Because U is opposite to the direction of the light coming from the source. So from there you will get a minus 2 there, a minus 2. 2 means what? If you are getting a value which is more than 1, then obviously you can say it is a magnified image. And a negative sign gives you the idea that negative sign which is falling downside to the principal axis, so this will be negative. So definitely this will be a real image. And next one is that it is an inverted image. Inverted image, that is negative sign. So then one more inference you are getting out of this particular magnification, that is you are getting a positive value or greater than 1 value. So obviously this will be a magnified image. So you got the position, that is 25 centimeter. The 25 centimeter is a position, and real image, inverted image, as well as magnified image. So the magnification of the, not the height, magnification of it. So here you can see that height of the image can be calculated is equal to Hi is equal to 2 into Ho, where Hi is equal to 2 into Ho. What is Ho? That is 7, that is 7, that is equal to 14 centimeter. That is minus 2, minus indicates inverted image, and 14 centimeter is the length of the image formed there. Okay, so a 7 centimeter object have a 14 centimeter image. That is 2 times the bigger than the object. So these all are the inference that you are getting out of this particular sign convention as well as the lens formula. Okay, so we will go with one more question and we'll wind up the class. Okay, let us go to the next question. Okay, just imagine that you have another lens in your hand. Which lens? It is a concave lens. Okay, let us imagine that you are given with an object which is placed 50 centimeter from the lens. 50 centimeter, 50, okay. And you are also given one more idea, one more value, that is the focal length is given as 10 centimeter. And you are asked to find out the position of the image. So what will be the position? Here the object I am just taking, that is, this is my object, and which is 50 centimeter from the optical center, right? And the light is falling from the object to that particular lens. So this is a direction of the light falling, or incident light coming from the source. And let us see what happens here. Okay, by the lens formula, 1 by f is equal to 1 by v minus 1 by u, and also 1 by V is equal to 1 by F minus will be changed to positive. Why? Because it is taken to the other side and that is equal to U. Now what happens here? 1 by V is equal to 1 by what is F? That is 10. But we need to know whether it is positive or negative. Which lens is this? This is a concave lens. And concave lens is what type of lens? It is a diverging lens. So obviously your focus, principal focus will be falling on the left side of the particular lens in this case, or otherwise we can say it is a virtual position, so you will get the same side of that of the object. So somewhere here you will get the focus, so focus will be negative. Why? Because focal length is calculated from optical center to that particular point. Which point? The principal focus. So this will be opposite, always opposite to the direction of the incident light coming from the source. So obviously the focus will be negative in this case. Plus, what is the next thing? That is minus, plus what is 1 by U? So that is 1 by U. U is 50, right? And one more thing is there. What is U? U will be always negative centimeter. So this will be the case. And one more thing you need to check is that whether the value you're getting is negative, right? Always negative. Why? Because you're using concave lens there. Concave lens will always give you a virtual image. And negative side of V means what? The V is also calculated from the optical center to the left side or opposite to the incident light, right? Okay, so here also V is equal to this much, and that negative sign shows that it is coming to that side, the same side of the object. So obviously this will be what? A virtual image. And if you are asked one more question, that is, what is your magnification? So it will be equal to minus, okay, M is equal to V by U, and V is what? Minus 8.33 divided by, the next thing is that what is U? U is 50, right? U is which? What is the value of U? That is negative. So negative, negative cancel, and you will get a positive value, and that you will get one more thing, and a value which is less than, that is something less than 1, and something you just calculate the thing and you will get the answer, and which should be less than 1. What indicates that? What is that? What does that mean? That is, what is less than 1? Less than 1 means it is a diminished image. So virtual, and the next inference you are getting is that it is a diminished one. Why? Because you are getting a value. What value? That is the magnification, which is less than 1, which give you a diminished image. And if you're getting a value which is greater than 1, then that means what? You have a enlarged image. So M greater than 1 indicates enlarged, less than 1 indicates diminished. So here you are getting a diminished image, a virtual image, and also the positive value of this M. What inference? It is upside. It is upside. Why? Why? This M is also can be calculated as HI by HO, and that value is what? HI is positive, and or simply you can say H this one and is equal to M. Okay, so from there HI is equal to M is positive into HO is always positive, and that is positive into positive, then definitely you will get a positive value, and which gives you that it is a erect image. So you are getting a lot of inference from this particular session, that is the lens formula as well as the sign conventions. This is why sign convention is so important that you should not miss out this particular section. Okay, so again we'll just brief the thing and we'll just wind up the session. 1 by F is equal to 1 by V minus 1 by U, where F is the focal length, V is the image distance, and U is the object distance. So that's very important. And the magnification is given. Magnification in the case of a lens is given by a different formula, which is denoted by small letter m, that is equal to the ratio of height of the image to ratio height of the object, that is hi by ho. In terms of v and u, or image distance and object distance, it is given by v by u, or the ratio of image distance to the object distance. So this is a second important equation. So let us, and the inference. Positive side or magnification less than 1 indicates it is diminished image. Magnification greater than 1 indicates enlarged image. Magnification equal to 1 indicates V is equal to U, as well as HI is equal to HO. And positive side of M will indicate that the image is erect. And negative side of the magnification indicates that it is upside down. So that's it. I hope that you got the points, you got the physics story behind the lens formula as well as sign convention. So make sure that you studied well. The idea should be there, crisp and clear, and just go through the videos which is made in the previous session of mirrors 2. So I'll pin it somewhere here. Just kindly go through that thing. And now we need your support as you're supporting till now in terms of your like, share, comment, and subscription. Do watch, support, and till we meet again in the next class, goodbye and have a nice day.